Hi, I'm Lee, and this is NASA Now. Today we're going to learn about a remarkable satellite and an instrument on board that will provide key information on the connection between the ocean and how it affects our daily lives. That's ahead. First, here's what's happening at NASA Now. The launch of the SAC-D satellite carrying Aquarius is a history-making event. Aquarius is designed to be the first satellite to measure the salinity or saltiness of Earth's oceans. Ocean surface salinity varies from place to place and over time. Aquarius will allow scientists to trace the ocean's role in Earth's water cycle. The mission is a partnership between NASA and the Space Agency in Argentina. In addition to Aquarius, SAC-D satellite carries 7 other instruments that will collect environmental data for a wide range of applications, including studies of natural hazards, air quality, land processes, and epidemiology. Now, let's take a look at the past.
June 19, 1999, just 12 years ago, the QuickSat satellite was launched to track global weather abnormalities. This mission helped scientists determine the location, structure, and strength of severe marine storms like Hurricane Katrina.
What difference does the saltiness of water make in our weather? We turn to David Levine for some insight. He's the principal investigator of the Aquarius mission from Goddard Space Flight Center in Greenbelt, Maryland.
Aquarius is an instrument to measure sea surface salinity, the saltiness of the ocean. I'm sure that you've had an opportunity to maybe swim in a lake and then swim in the ocean, and you know that the ocean is different, tastes different, and that's the salt in the ocean. You float different in the ocean than you do in a lake, and that's because the saltiness of the water changes the density, the buoyancy of the water, makes you float a little bit easier. Typically what happens is water starts in the tropics, for example, where it's warm and salty, and gives off its energy to the atmosphere, cools down. As it cools down, it gets more dense and it sinks. And so you have this motion of water from the tropics, from the equator, northward, where it's cooling and getting more salty, and then it moves on the bottom of the ocean back towards the tropics. This is called ocean circulation, and what it's doing in addition to moving water is it's moving heat. It takes the warm water in the equator and it moves it towards the North and South Pole. And so we're very much interested in the saltiness because how the oceans move affects the distribution of heat and how that affects our climate, whether our summers are warm or cold. Imagine Aquarius being a night goggle in space. It looks down at the ocean, it detects the energy from the ocean, and that energy changes as the salinity changes. So by looking at those changes, we can calibrate the change to salinity and get a measure of the sea surface salinity content. So if the salinity were to dramatically change, if melting glaciers in the North Atlantic added a lot of fresh water, which caused a change in that circulation, we could have major changes in the climate in the northern regions. Europe would be very cold. The southern regions could be warmer because the heat wasn't being moved northward. Oceanographers, scientists who are interested in the ocean have recognized the importance of salinity, and salinity measurements have been made for at least 100 years. But basically the measurements were made by taking water samples from a ship. And now Aquarius is going to do the same thing from space. And what's important about measuring from space is we can see the whole globe in a short amount of time. To put it in perspective, Aquarius, in its first month in orbit, will make as many measurements as were made from ships in the last 125 years. Aquarius is designed to monitor the whole globe, that is to make measurements over all of the oceans in the globe every 7 days. So it orbits about 14 times a day, and the orbits move around, so after 7 days all of the oceans are covered. Our goal is a 3-year mission. Our hope is that it'll be 5 years or more.
Did you know the composition of a single crystal of ocean salt is so complicated that no laboratory in the world can produce it from its basic 80 chemical elements? Now you know.
Now it's time to check out what's up.
If you would like to watch satellites cross the night sky, check out the website heavensabove.com for a complete list of sky watching opportunities in your area. Then grab your binoculars and watch for visible passes of the International Space Station, Nanosail D, and many more.
Teachers, now that you've seen how sea surface salinity affects climate, let your students explore all the factors that determine climate.
The Earth Climate Course content module gives students an opportunity to use science and mathematics concepts to explore the factors affecting the habitability of planets. Look for this activity under Teaching Materials on the NASA Explorer School's virtual campus.
Well, that's it for NASA Now. Be sure to tune in next week when we take you on a journey to the beginning of our solar system with Dawn. We'll see you then on NASA Now.
NASA Now comes to you from the virtual campus at NASA Explorer Schools.